Hello, welcome to Tennessee's at-home learning series for math. Today's lesson is for all our 8th graders out there, though all students are welcome to tune in. This lesson is the 20th in our series. My name is Candace Thompson, and I'm an 8th grade math teacher at Oakland Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson today. Welcome to my virtual classroom. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education's website that I have pulled up here, as well as our lesson plans and student packet that has the independent practice you can complete at the conclusion of today's lesson. You can still tune into today's lesson if you haven't seen any of our others, but it might be more fun if you first go back and watch our other lessons, since we'll be talking about things we learned previously. Today, we will be learning about using formulas to find the volume of real-world objects shaped like cones. Before we get started, to participate fully in our lesson today, you will need paper and a pencil and a surface to write on. Calculator or calculator app is useful, but not necessary. Okay, let's begin. Whether or not you know it, you are probably very familiar with cone-like shapes. Lots of real-world items are shaped like a cone. Funnels, party hats, and of course, ice cream cones. In lesson 19, we found the volume of cylinders. This lesson is focused on cones, and there are a lot of similarities. A cone has one circular base and a curved lateral surface. A cylinder also has a curved lateral surface, but it contains two congruent circular bases rather than just one. Another similarity in the measurements required to find the volume in a cone. Much like cylinders, you need to know the area of the base or its radius and the height of the cone. One difference, however, is the height of a cone versus a cylinder. A cone actually has two aspects that are referred to as height. The height of a cone is the length of the segment from the vertex perpendicular to the center of the base. Recall that the vertex is a special point in an object, usually where two or more lines or edges meet. Let's look at a picture of a cone here. A cone also has a slant height. This is the length of the segment from the vertex to any point on the circumference of the circular base. Talking about this here. So how do you find the volume of a cone? The volume of a cone with a radius r is 1/3 the area of the base b times the height h. Here is the formula. Be sure to write these down because we will be using them later. So you would write volume equals 1/3 of the base times the height, or volume equals 1/3 pi r squared, because that's the same as the base, times the height. Notice in the similarity to the formula we learned for cylinders in lesson 19, which you may recall looks like this. Volume equals base times height, or volume equals pi r squared times height. So this is cylinder, this is cone. If we were to find the volume of a cone, then turn it into a cylinder with the same base and the same height, could we use the cone volume to find the cylinder volume? Yes, we could. How would we do that? That's right. We would only need to multiply it by 3 because the cone's volume is only 1/3 of the product of the new cylinder's base, area, and height. You may also recall from the cylinder lesson that sometimes we are provided with a measurement for diameter instead of the radius. As long as you remember that diameter is twice the radius, you will be able to determine the radius and use the formula you've learned. Remember, radius is just the diameter divided by 2. Now that you understand what to look for when finding the volume of a cone, let's try some application problems together. Recall that during our lesson on finding the volume of a cylinder, we mentioned some steps that are very helpful when solving the formula for volume. Substitute, simplify, and multiply. These will also be useful when solving for volume in cones. Let's find the volume of this cone here. First, let's start with our formula and substitute the actual measurements for height and radius. You follow along and write this down with me. So volume equals 1/3 pi r squared times height. So volume is 1/3 times 3.14 times 2, that's my radius 2, squared times my height of 8. Next, we will simplify. So I have 3.14 times 4 times 8. Finally, let's multiply our numbers to find the solution. So we have 33.5 cubic inches. So the volume is about 33.5 cubic inches. Recall from the cylinder lesson that our answer is cubed because the volume is the number of cubic units needed to fill in a given space. Also, remember we use this approximation symbol, which means almost equal to, because the value substituted for pi, 3.14, is approximate. So the answer must also be approximate. Let's work together on another problem. Listen to the details. For her geography project, Karen built a clay model of a volcano in the shape of a cone. Her model has a diameter of 12 inches and a height of 8 inches. Find the volume of clay in her model to the nearest tenth. Use 3.14 for pi. Did you notice in this problem we're given the diameter, not the radius? But this won't be a problem for us because we know that the diameter is twice the radius. So we can easily figure out the radius. Radius is just diameter divided by 2, which in this case would be 6 inches. Now that we know the radius is 6 inches, we can find the volume of clay in Karen's model. Let's start with our formula, making sure to substitute the problem's measurements and simplifying where necessary so we can multiply and come up with our own answer. You follow along and write this down with me. So volume equals 1/3 pi r squared times height, which is going to be 1/3 3.14 times 6 squared times 8, which is going to be 3.14 times 36 times 8. So we get 301 and 4/400 as our answer. So since we are rounding to the nearest tenth, the volume of the clay in Karen's volcano is about 301.4 inches cubed. You're really getting the hang of this. Let's look at a few other problems that involve both cones and cylinders. Remember, we said there are a lot of similarities between the two. And that's true. And if you already know how to find the volume of a cylinder, then you can most definitely find the volume of a cone. Here is our problem. The area of the base of a cylinder is 45 square inches and its height is 10 inches. A cone has the same area for its base and the same height. What is the volume of the cone? The base area and height is the same for both the cylinder and the cone, so we can use the information to find the volume of the cone. So volume equals 1/3 base times height. So in this case, it's 1/3 45 times 10. 1/3 45 times 10. So this would be 150 cubic inches. The volume of the cone is 150 inches cubed or cubic inches. What if we also wanted to know the volume of the cylinder? Because the cylinder and the cone have the same base and the same height, then you can use the information to find the volume of the cylinder. So volume equals a base times height. Volume equals 45 times 10, which equals 450 inches cubed. Note that the volume for the cylinder is 3 times that of the cone. Therefore, this means that all cones have only 1/3 of the volume of their related cylinder. Related meaning they have the same base and height. Okay, so let's take a look at one more problem, and this one's a little tricky, so pay very close attention. All right, so the tip of a sharpened pencil is shaped like a cone. How much of the pencil is lost after the tip is formed? Use the measurements in the picture to solve the problem. So as you can see, the tip of this pencil was formed out of a cylinder with a height of 0.8 centimeters, and here's the height, and a diameter of 1 centimeter. First, let's find the volume of our cylinder. Write down the steps and follow along with me. So I'm going to write down cylinder so we know what we're working on first. So we have volume equals pi r squared times height. So 3.14 times 0.5 squared. I just cut that diameter in half. Times 0.8. So I have 3.14 times 1 times 0.8. So let's plug that into our calculator. Oh, I found an error in my work. So if you notice right here, I just did 0.5 times 2 instead of squaring it. So really what this should be is 0.5 squared, whoops, try that again, 0.5 squared, that should be 0.25. That's why you should always check your work and not go super fast. So now what we're going to do is multiply all of this together. And our answer is 0.628. And let's see if it told us what to round. So, okay, so this means that the cylinder, let's round that to the nearest tenth. So we have 0.63. Okay, so this means that the cylinder had a volume of approximately 0.63 centimeters cubed. Let me write my units of measure here. Now we can use this to find the volume of the cone. So the volume of the cone is going to just be 1/3 the volume of the cylinder. And remember, that's only because they have the same height and the same base or radius. So the volume of the cone is equal to 0.21 cubic centimeters. To find out how much volume was lost, we're going to subtract the volume of the cone from the volume of the cylinder. Did you get the answer? So we're going to subtract the volume of the cylinder from, or minus the volume of the cone. And that's right, we should have got 0.42 centimeters cubed. So before we move on, let's recap on a few things we've learned about finding the volume of cones. Jot these down and keep them in mind while we work on a few problems. I'm going to actually write them down with you. So, as with the cylinder, you need the radius and the height to determine the volume. So need radius and height to determine volume. If only the diameter is provided, remember that the diameter is twice the radius. So diameter is twice the radius, and we can get the radius by dividing the diameter by 2, okay? As with a cylinder, the volume of the cone will be an approximate number. So volume is an approximation because what we're using for pi is 3.14, and that's an approximate number. Next, the volume of a cone. So volume of a cone is 1/3 the product of the area of the base and the height of the cone. And then if you have a cone and a cylinder that are congruent, same area and same height, so let's write that down here. If you have a cylinder and a cone that are congruent, meaning same area of base, same height, and you know the volume of the cone, you can multiply it by 3. So volume of the cone, you can multiply it by 3 to get the volume of the cylinder, okay? All right, so let's move on to some more problems. You've probably noticed that we've been looking at a lot of diagrams of cones as we did the previous lesson in diagrams of cylinders. Reading a diagram accurately is important when solving problems. So let's take a closer look at these two here. Notice that the diameter and the radius of the base are shown by a solid line. Solid line. Radius, well, that's diameter. Diameter and radius. The height of the cone is a dashed line. So no matter how this cone is oriented, that height is always going to be a dashed line. Does the diagram of cone A show the diameter or the radius? Right, it shows the diameter because the endpoints are along the circumference of the base. They go all the way through the circle. So that means cone B must be showing the radius. But what is the radius of cone A and how do we find it? Remember that the diameter is twice the radius. A simple formula shows this, that diameter equals 2r, or that radius is just diameter divided by 2. Knowing this, what is the radius of cone A? Yes, it is 5 centimeters. Now, let's find the area of the base of cone A. Try to follow along with me and write down the steps of the problems. Remember that the formula for finding the area of the base is as follows. B equals pi r squared. Let's substitute the information we know and find the area of the base. So base equals 3.14 times 5 squared. So 3.14 times 25. That's going to give me 78.5 centimeters cubed. So now that we know the area of the base is 78.5 centimeters cubed, we can easily find the volume of cone A. Let's use our formula. Volume equals 1/3 pi r squared times height. So that's 3.14. Let me back up a little bit, sorry. So we know, well, yeah, so that's 1/3. We've already figured out this part. That's our base. So we can do 1/3, our base, which we just figured out was 78.5, times our height, which is 10. So that is going to be equal to 261.7 cubic centimeters. Did you get that answer too? The volume for cone A, rounded to the nearest tenth, is 261.7 centimeters cubed. So since we already know the height and the radius, let's go ahead and find the volume for cone B. Let me make sure I write down that this is cone A. I'm going to highlight that for you so we don't get our work confused. All right, so get your pencil and paper ready, and let's look at cone B. So we have volume equals 1/3 pi r squared times height. So that's going to be 1/3 times 3.14 times 4 squared times 8, which is going to be 1/3 times 3.14 times 16 times 8, which is going to be 1/3 times 401.92. And finally, that's going to be 133.97333 cubic centimeters. So if we round this to the nearest tenth, our answer is 134 centimeters cubed for the volume of cone B. Let's try another. Get your pencil and paper ready and we'll try this one together. All right. So Lucas makes models of cones to explore how changing dimensions affect volume. Cone A is 10 centimeters high and its base has a diameter of 4 centimeters. Cone B is twice as tall with a height of 20 centimeters and a diameter of 4 centimeters. Cone C is the same height as cone A, 10 centimeters, but the diameter of its base is 8 centimeters. That is a lot of information, so it might be helpful to make a table like this one so that you can organize your measurements. If you recall from our previous lesson on cylinders, we did this when we were working with 3 candles with different heights of volumes. So here is our chart. Take a moment and write down a chart like this. So let's fill in the information we've been provided with in the problem. We know that cone A has a height of 10 centimeters, so we can add that. We also know that the diameter of cone A is 4 centimeters. So it says that right here, diameter of 4 centimeters. But we need to find the radius for our table. How do we find that? Did you remember that the diameter is twice the radius? So what would the radius be for cone A? Yes, that's right. It would be 2 centimeters. We'll put that measurement in our table as well. Now, what else does our problem tell us? Again, we have a height and a diameter for cone B. So let's fill in what we know. So cone B is twice as tall with a height of 20 centimeters and a diameter of 4 centimeters. So we know that the height is 20 centimeters. Now, once again, we're given the diameter. So once again, we'll take half of the diameter, which would give us a radius of 2 centimeters. We'll add that to our table. And then finally, we have cone C. It has the same height as cone A, so a height of 10 centimeters. And then, let's see, it has a diameter of 8 centimeters. So again, we're going to have to divide that diameter by 2 to get the radius, and we would have 4 centimeters. All right, does your table look like this? Good. Now we can find the volume of all 3. First, let's work on cone A. Recall your formula for volume and try to work along with me. If you have 1, you can use your calculator as well. So we have, I'm going to write cone A here just so we know what our work is. So volume equals 1/3 pi r squared times height. So 1/3 times 3.14 times 2 squared times a height of 10. Whoops, I don't square the height. So that gives me 1/3 times 3.14 times 4 times 10, which gives me 1/3 times 125.6, which gives me 41.8. A lot of 6s. 1, 2, 3, 4, 5, 7 cubic centimeters. Whoops, went off the page. There we go. All right. So if we round this to the nearest tenth, we will have 41.87 cubic centimeters. Now let's work out the volume of cone B. So we have volume equals 1/3 pi r squared times height. So I have 1/3 times 3.14 times, let's see, radius is 2, times a height of 20. So that's going to give me 1/3 times 3.14 times 4 times 20. 1/3 times 251.2. And then that's going to give me 3.7. So if I round that to the nearest hundredth, I will have 83.73 centimeters cubed. All right, so I've done 2 for you. I'm going to let you do the volume of cone C on your own. All right, so you should have the volume of cone C, and your table should look like this. So now that we have this information, we can better evaluate the size, shape, and volume of our cones. For instance, how much greater is the volume of cone B than cone A? So we can just subtract those two values. This is the volume of cone B minus the volume of cone A. So see if you can get the answer and round to the nearest tenth. Did you get 41.9 centimeters cubed? Great job. So you've done some great work in finding the volume of a cone. I hope that you keep in mind the formulas and tactics that have been shared. And after this lesson, if you'd like some more practice, you know where to find it on our website here. Students, I enjoyed using formulas to find the volume of real-world objects shaped like cones with you. Thank you so much for inviting me into your home. Goodbye.